I'm excited. Monday is not only Independence Day, it is a very exciting day for people who are fans of space. Joining us right now via Skype, Dr. Phil Valek. He's a principal scientist at Southwest Research Institute. Dr. Valek, thanks for joining us.
Oh, thanks for having me.
This has been a mission that's been going on. Juno was launched 5 years ago, right?
Yes, 2011.
And you, by the way, are responsible for Jade, which is one of the instrumentation packages on there. What's going to happen on Monday?
So what's happening on Monday, what's happening right now, is we're getting closer and closer to Jupiter. And right now, the Juno spacecraft and Jupiter are both in orbit around the sun. And so as we get closer and closer, the gravity's pulling harder and harder on us. At some point, we have to slow down enough so Jupiter can capture us, so we go from being in orbit around the sun to being in orbit around Jupiter.
So Jupiter's gravity will actually grab Juno and pull it.
Well, it's doing part of that, but you're going to see in a second here, if this is the video I'm thinking it is, you're going to see the main engine burn kick in. And yeah, you see it's making a maneuver here. It's turning. So before then, it was facing the sun for the solar panels. Now it has to turn, so it's pointing away. It's speeding up, so we get a little more stable. And then any moment now, it's the main engine's going to fire, and that's going to be slowing us down. So it's coming soon. Better turn on.
Any minute now.
Oh, come on.
Are you going to be?
There it goes.
Are you going to be watching this exact maneuver with great interest?
So there's going to be a lot of us there watching it with great interest.
Yeah. Is this risky? This part right here?
This is probably This is the next most risky thing. The most, on any mission, the riskiest part is launch.
Right.
You're on a massive rocket with so much explosive power.
You're sitting on a controlled explosion and hoping it pushes you in the right direction, basically.
It's amazing how successful we've gotten at those. It's really a testament to the engineering and the great work people have done over the years. But yeah, so once we get there's this 35-minute burn, and that's going to slow us enough that we get into orbit. And there's going to be a lot of us here watching it very closely and waiting to find out. One of the kind of the nerve-wracking things is the round-trip light time is so long that it's pretty much going to be done and over before we even know on Earth. So
how long does it take to get a signal from Jupiter?
It's about 40 minutes now.
40 minutes.
Yeah.
Wow. So how close? It's going to go in orbit. How close will its orbit be?
So we're going to be a couple thousand kilometers. I'm going to get these numbers wrong. A couple kilometers above the cloud top. So
and what will we be looking at?
Okay, so a bunch of things. In this first orbit, this JOI, not really much. It's such a critical maneuver that all the science instruments are going to be turned off because we don't want anything to distract the operations team. But then we get into this large capture orbit, it's a 53-day orbit, and the next one coming through is when the real excitement begins.
So it's a very elliptical orbit. So you're going to go fairly far from Jupiter, but then you come around and get very, very close.
Yes.
Got it.
It's a bit of both. One of the reasons we're going so close, skimming the cloud tops, is Jupiter is a very harsh environment to be in. Yeah. You have these enormous radiation belts, and so by coming in so close, we're kind of sneaking underneath them. And it's one of the things we're doing to protect the spacecraft and the instruments as long as we can.
Radiation was one of the issues all along. 20 million rads it's going to absorb during its lifetime.
Yes.
Is that a lot?
That's an awful lot. Right? We're like at 0.3 rad here. So a typical mission, if it's 100,000 rad, you're thinking that's a lot. So this is just a whole nother ball game.
How does that change what you do as an instrument designer?
Well, one of the things we did, one of the very innovative things, is we have the vault. So if you look at the spacecraft, underneath the high gain antenna, and so you can't quite see it from there, but if you look underneath it, there is a large, you can see the box right there. There's a large titanium vault.
Yeah.
And inside there are all the electronics that can live in there, the computers, the avionics, the power supplies. And you could see these sensors are on the outside, the cables running out to them. So the stuff that, if everything was in the vault, couldn't see anything, so it wouldn't be much of a science mission. So the things that have to be outside looking are outside looking.
So what happens when the mission's over? Does the spacecraft remain in orbit around Jupiter, or does it fall in and be gone forever?
It's going to fall in. So there's something called planetary protection. there's the moons of Jupiter. We're finding out all kinds of amazing things, and we don't want to have any possibility of contaminating those. So our last orbit is falling into the changing orbit a little bit, so we accelerate into the cloud tops.
Wow.
And nothing's going to survive that. So it's
you want it to burn up. You want it to.
Yes.
Yeah.
And you're gathering data the entire time through the destruction,
Yes.
right?
Wow.
Yeah.
This is so. We live in amazing times. This is
Science
really
fiction.
remarkable.
It's science
yeah.
fiction.
So tell us about Jade. What is that?
Okay, so Jade's, it's the Jovian Auroral Dynamics Explorer. So just like at Earth we have auroras. If you live at northern or south, far enough north, far enough south.
The Northern Lights.
Northern Lights. Jupiter has northern and southern lights, but they're different.
A little
so
bigger.
some ways we think they're very similar in the sense that we think it's the same mechanisms kicking them off, but Jupiter is very different than Earth, and the auroras are different. So this picture you're showing up right now, there's basically 3 categories of aurora. There's something called the main oval, and there's a kind of if you look at it, kind of a complete circle that's around there. Inside that, there's a diffuse aurora, and then outside, I think it's one of the coolest things, you see kind of like a spot with a tail coming off it. Those are auroras that are coming from the moon. So that's from Io. Io is the most volcanic body in our solar system. It's putting off a ton of material a second. It's not the figurative, it's a ton, big number. It's 1,000 kilograms a second of material. And as it comes off, it runs down the magnetic field lines, and those particles, some of those particles hit the upper atmosphere of Jupiter and cause it to fluoresce and give lights. And so you look at some of these dots out there, looking at the footprints of the moon. So if you could see the magnetic field lines and trace it out, you'd see where the moon was.
Wow, would you like a GF8 right down there and take some of those nice
I
aurora
would.
pictures? That'd be
I
beautiful.
want to see that photo again. I saw a smiley face on top.
Was
of it.
there? I think
Did you
maybe.
see it?
Yeah, it looks
Look
like
right
there's.
there.
Yeah.
Can you see it right on top of the planet?
Yeah,
right
actually
there?
looks like Napoleon. But anyway, so will we get pictures, like visual pictures we can see? Is that something we want, or does that even matter?
Yeah, we will be getting pictures. There are pictures from the Hubble Space Telescope being done. We have a lot of campaigns working with them. But the Juno spacecraft has its own set of cameras too.
Yeah.
There is one called UVS. It's an ultraviolet spectrograph. The blue images of aurora you saw there, that was in the ultraviolet. There is an instrument called GERM, which is an infrared camera. GERM is, we'll look at the infrared, as the name suggests, so we could see the aurora in a different wavelength, but it also can see kind of the heat map of the whole planet. And then there's one instrument called Juno Cam, and Juno Cam is kind of unique because Juno Cam is really put there for the general public, and it's an outreach. So if you go to our website, missionjuno.swri.edu, there's a portal there where you can start, and they'll show a map and vote on things for it to look at, to focus on. The data will be there. You can comment. We want everyone commenting on the data, and the data will be there. So if you're an amateur astronomer and do data processing, image processing, you could take it, download the data, and work on it. So
that's really cool.
That's crazy.
Yeah, you were talking earlier about wouldn't it be great to send your camera there? Well, we kind of beat you to it.
We sent one there for you.
We sent one for you, so don't worry. You can keep your camera safe.
What do scientists think is inside Jupiter? I've heard that it's a liquid mercury core, or
so liquid hydrogen, and so it's even more crazy. But part of the question is the honest answer is we don't know. There's a couple of theories within there.
That's why it's my favorite planet.
Yeah, if you look, these gorgeous images, and all you're seeing is the surface of it. So one of the big parts of this mission is figuring out what's in there. One of the theories is its pressure is so immense that the hydrogen is being compressed so much that's a liquid hydrogen core. So one of the things we're going to figure out, how we're going to figure out what's in there is one of our experiments is a gravitational experiment. And so as we go around the orbit's going to be perturbed slightly depending on what's the details of the mass inside. The gravitational forces will change a little bit. And so from that, we can kind of peer underneath the clouds and see what's in there.
Wow.
The other way we're doing it with our magnetometers. So we have, by mapping the magnetic fields very accurately, we should be able to figure out what's causing the magnetic fields, what's the structure there. And these will be the 2 ways we're going to be peering under the cloud tops.
So we really only see the cloud cover.
Yeah.
We've never seen what's beneath the cloud cover.
Yeah, I mean, in some different wavelengths, you could see a little bit deeper or not quite as deep depending on there, but yeah, you're just looking at the skin. I mean, the very tops of it.
Wow.
Jupiter is just a place of mystery right now. That's one of the reasons missions is so cool and exciting. We are going somewhere that no one has ever been. There's been 7 missions that have flown by Jupiter, or the Galileo mission's been in orbit around Jupiter, but none of them have ever gone over the poles, and has gone as close as we're going to be going. So this is going to be, when you go someplace new or you look differently, you're going to find out whole new things, and that's what we're doing here on both of those. So
NASA has gotten so sophisticated about its outreach, and I'm really glad. I mean, the videos you see, the websites, the Juno cam, they've really gotten good about reaching out to normal people to get them excited about what's going on. Yeah. Is there a way people can participate tomorrow as you do the orbital insertion? I know NASA has a Snapchat channel that you can watch some stuff.
It's got a Twitter feed. It's got a Facebook. But you were showing at the beginning the video of coming in. Well, that's Eyes on the Solar System. And Eyes on the Solar System is an application developed at JPL that has incredible details of the whole solar system. You can spend, I don't know how many hours I've worked on this application.
Wasted?
Wasted. I've
worked on.
Edit.
When you go on this, you can spend hours going around. It has a huge number of missions. You can go find out where any of these are at any point. There's a special Juno module there. You click on it, and during the flyby, it's going to be in real time. So what you showed right now was highly sped up. It was a 35-minute burn, and showed him a minute or so. But it's going to be going in real time. So, the best places to see it will be, I think they said Jupiter, which no one's going to get that one, unfortunately. Going to be here, maybe at JPL, and then at your computer watching it in Eyes on the Solar System. So if you want to see what's really going on, this is the application to see. So if anyone there is interested in space, this is something you should definitely download for your computer. It's a great application.
When do we get to send men or women to walk on Io?
Well, I'm not sure that, but there's one of the things. We do have 3 little passengers on the Juno spacecraft. There are 3 little Lego figurines.
Nice.
Because there was a joint agreement with Lego. They're made out of space-grade aluminum because we're very contamination, and I'm very strict on what materials can be on a spacecraft. So you couldn't just throw 3 Lego figurines. But flying on it right now, there's Jupiter, Juno, and Galileo. So that's the fun little thing. It's one of those little
on the planet permanently, right?
Well, 2 days, 4 hours, 55 minutes, and 19 seconds from right now, orbital insertion. And I know exactly where you will be, Dr. Phil Valek, watching closely with the rest of the world as yet another amazing scientific mission, an unmanned mission from NASA. Really, really cool stuff. Thank you so much for spending some time with us and getting us excited about this.
Oh, thank you for inviting me. This is a lot of fun.
A lot of fun. Dr. Phil Valek is a principal scientist at SWRI, Southwest Research Institute, where they made the Jade instrument that's going to measure the aurora as they get closer and closer to Jupiter. Thank you, Dr. Valek.
Thank you.
Appreciate it. Take care.